Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, which is a pure mathematics one for October-November 2020, and the code is 9709/11. So let's move on to question number 1. Okay, for question number 1, find the sets of values of m for which the line with equation y equals to mx minus 3 and the curve with equation y equals to 2x squared plus 5 do not meet. So when do not meet means that there is no intersection point. Okay, but even though there is no intersection point, we still need to solve the simultaneous equation first. Then later on, we let the discriminant be less than 0 so that there is no solution. Okay, so y equals to mx plus minus 3, first equation, and then the curve equation, I will just rewrite here. Then now, when solve these two simultaneous equations, in order to get the intersection points, right, you just let first equation equals to second equation. So it means that I will be getting mx minus 3 equals to 2x squared plus 5. Okay, then from here, since I'm getting 2x squared on the right side, means all the terms from the left side will be moved to the right side. So from here, I will be getting 2x squared plus 5 minus mx plus 3 equals to 0. Okay, so from here, just need to rearrange it. So it will be 2x squared minus mx. Now the 5 and 3 together will be plus 8, then equals to 0. Now, as I've mentioned just now, since they do not meet, and now we are solving this, we are getting this quadratic equation after we assuming they are intersecting. Okay, so I just need to show that there's no root for this intersection equation. Then imply that it will not be, well, both of the graphs do not meet. So now my A is 2, the coefficient for x squared is 2. My B is a coefficient for x, which is minus m. And then the C is the constant, which is the 8. So now use the discriminant method. B squared minus 4AC less than 0. Okay, so from here, just replace the values and you will be getting this inequality. Then I will be getting m squared minus 64 less than 0. Now, for this quadratic inequality, we have a formula over here. A squared minus b squared is basically a minus b multiplied with a plus b. Okay, so the 64 I can change to 8 squared. So when you compare, that means your a is m and then the b is b is 8. Then I will just apply this formula. It will be m minus 8 times m plus 8 less than 0. Okay, so now to get the solution over here, refer to this graph. This graph, okay, this is 1 positive 1 m squared. That means this quadratic curve will have a minimum point. So now I will just simply sketch. This is my m axis. So now the points on the m axis will be the m values that we get it from the brackets. So just let m minus 8 be 0, you will get 8. When m plus 8 equals to 0, you will get minus 8. Okay, and now for final answer, refer to this inequality sign. Since this is less than 0, that means it will be below the axis. So obviously, from here, I will be getting minus 8 and 8. That is my solution. Okay, for question number 2, the equation of the curve is such that this is the dy dx. Is given that the curve passes through the point. Find the equation of the curve. So for your information, when y you differentiate it with respect to x, you will be getting dy dx. And now you are given dy dx. To get y from dy dx is basically reverse process. This is the integration. Okay, so now I will rewrite the question. dy dx equals to, now instead of writing this form, I will just move up the numerator and move up the denominator. So it will be x minus 3 negative 2 to the power of negative 2, then plus x. Now again, based on this concept, my y is integration of x minus 3 to the power of negative 2 plus x dx. So when we do integration, the formula is integrate ax plus b to the power of n dx. It will be rewrite the whole function. Then the power, instead of n, you change to n plus 1 over n plus 1. And then after that, you differentiate ax plus b. That will be a. And then followed by plus c. This is the formula, which means you always plus 1 degree to the function whenever you integrate it. That means now here, I will rewrite the function. Minus 2 plus 1 is basically minus 1 over the new degree. And now when you differentiate x minus 3, because of 1x, so you will get 1. And for the right side, x, you change to x squared over 2. And then followed by plus c. And now I rewrite, I simplify it first. So now, for the first term, because this is negative degree here, so you have to move it down. And then there's a negative at the bottom as well, so I will write negative 1 over x minus 3. And then second term is x squared over 2 followed by plus c. This is your expression for y. And now to get the complete equation of the curve, you need to find the c value. So to get the c, substitute the point. Okay, or just refer to the point to get the x and y coordinate. That means your x is 2, your y is 7. Then from here, I will get 7 equals to negative 1 over 2 minus 3 plus 2 squared over 2 plus c. Okay, then from here, I will get 7 equals to, now 2 over 3 is basically minus 1. So you get minus minus is a plus 1. Then plus 2 plus c. So from here, your c is going to be 4. Now equation of the curve is found. Just need to substitute this c into your y. So I will get y equals to negative 1 over x minus 3 plus x squared over 2, then plus 4. So that is my equation of the curve. Okay, question number 3. A is being pumped into a balloon in shape of sphere, so that its volume is increasing at a constant rate of 50 centimeter cube per second. Find the rate at which the radius of the balloon is increasing when the radius is 10 centimeters. Okay, now whenever you see rate, that means that is d over dt. And when you see increasing, it should be a positive value. Okay, so now it's mentioned that the volume of sphere is 50 centimeter cube. So I will write dv over dt. So by looking at the units here, centimeter cube is the units for volume. The s minus 1, this is per second. That is the units for time. That's why I get dv dt. And it is increasing. So it will be a positive value. That's why this is positive 50. Okay, and now you need to find out what is your dr dt radius, the rate of the radius, how much when the r equals to 10, radius is 10. Okay, so first of all, we need to find out what is the volume of the sphere first. So for volume of sphere, it is 4 over 3 pi r cube. Okay, now to get the dr dt, we need to refer to the chain rule. So chain rule is basically dr dt equals to dr over dv, because here you are given v, times dv over dt, which means now I need to find out what is dr dt. dv dt is given, then now I need to find out what is this dr dv. Therefore, I need to find the dv dr first. So now, by looking at the v expression here, dv dr, okay, you keep the 4 over 3. When you differentiate, you always bring down. Okay, so our formula is differentiate fx to the power of n, it will be n fx, the n minus 1 times f prime x. Okay, when you differentiate any function, let's say just x degree n, I will bring down the n, rewrite the x, and degree becomes minus 1. Right, n minus 1. So now from here, when I differentiate, I keep the pi, differentiate r cubed, it will be 3r squared. Then from here, I can simplify. The 3 can be cancelled off. So I'm getting 4 pi r squared. Okay, so you can find out first, when r equals to 10, what is your dv dr? So I'll write when r equals to 10, my dv over dr equals to 4 pi times 10 squared. So this is going to be 400 pi. Now, use this formula. Now, my dr over dt equals to dr over dv times dv over dt. So now we have found dv dr in the previous step, and now we need dr dv. So just for your information, dr dv is 1 over dv over dr. Okay, that means it's going to be 1 over 400 pi. So then from here, I will get 1 over 400 pi multiplied with 50. Okay, so when you simplify 50 and 400, it will be just 8. So I will be getting 1 over 8 pi. The units will be centimeter per second. So this is the solution for question number 3. Okay, next question, question number 4. In the diagram, the lower curve has equation y equals to cos theta. The upper graph shows the results of applying a combination of transformations to y equals to cos theta. Now find in terms of cosine function the equation of the upper graph. Okay, so first of all, we will see the transformation. Look at here. From 0 to 4 pi, I have two cosine graph. This is the first, and then this is the second. Right? So that means now here I will just write down from 0 to 4 pi. Okay, two curves for the original graphs, and then it changed to just one graph of the upper graph. So 1. That means my upper graph is half of the original graph because from 2 to 1. So which means, right, I will be getting cos half theta. That is my first. Okay, so second, I will check here my vertical distance. I want to find out what is the difference now. Then it has been changed to increase. Okay, so that means here at first 2 units for vertical distance. Now my new graph, the vertical distance from 1 to 4, that means it's 4 units. Okay, so that means here, right, vertical distance 2 to 4 units. Right, that means the new graph is actually double of the original graph. So now my second transformation is basically double of the function. Okay, double. Now then the next one is I need to find out. Now when you look at here, how much it has been shifted, because if it's the same shape, still same shape, right, same shape as the original, but then it is no longer start from 0. Okay, the symmetrical line is not 0. So now what to do is, instead of this 2, you divide by 2 because it will be symmetrical. Right, so that means when 4, I divide by 2, it becomes 2 units. So now you check here. From 0, change to 3. That means the graph has been shifted 3 units. Okay, so then from here, I will say shifted 3 units upwards. Okay, so when shifted 3 units upwards means that you have to plus 3. Okay, then from here, number 3 is 2 cos half theta, you plus 3. So I will write plus 3 over here. That means, okay, my new graph, so equation of the upper graph is basically y equals to 3 plus 2 cos half theta. So that is my new curve. And these three are the combinations of, these three are the transformations. Okay, now question number 5. In the expansion of this term, the coefficient for x degrees 3 and x degrees 6 are equal. Now, A, find the value of non-zero constant A. So what I need to do is I will just write this term or this expansion in summation form. This is basically summation 6r. This is 6cr. Then first term is 2x squared degree r, followed by second term is plus a over x. So a over x degree of 6 minus r. Then the r starting from 0 until 6. And now mention that the coefficient for x cubed and x degree 6 are equal. So before that, I just expand first so that I can see clearly my r value later on. So then what to do is this r bring into the terms inside the bracket. That means I will be getting 2 to the power of r, x to the power of 2 bracket r. Okay, and then this is going to be a to the power of 6 minus r. Then this x, I can write x power negative 1 to the power of 6 minus r. Then now if you want to rewrite or simplify the terms, here you will just write 2 to the power of r, x to the power of 2r. Okay, because our formula is a to the power of m, then another bracket n outside, the power outside means that a to the power of mn. Okay, so then from here, the other one is a to the power of 6 minus r, followed by x to the power of this minus 1, you times it to the 6 minus r. That means becomes minus 6 plus r. Okay, so now I need to find out what are my r values when x power 6 and x power 3. So when x power 6, okay, look at the term with the x. It will be two terms here. So now I will get x to the power of 2r times x to the power of minus 6 plus r. Okay, this is the method to find out the r. So now we have another formula over here. Since both with base x on the right side, so I will get a to the power of m times a to the power of n. It will be a to the power of m plus n. Okay, so now you just need to add up the power. So here will be x to the power of 2r plus minus 6 plus r. It will be x to the power of 6. Then now since both base are the same, so just ignore the base and compare the index. So I'll get 6 equals to 2r. So open the bracket, you get minus 6 plus r. Then from here, I will be getting 12 equals to 3r, hence my r is 4. Okay, so I know that when I need to get x power 6, my r is 4. So the coefficient of x power 6, it will be when r is 4. So I will get 6c4. Okay, just substitute back into this expression. No need to refer to the summation because summation is to give you the complete series. So here it will be 2 power 4. Then a to the power 6 minus 4. Then here I will be getting 6c4 times 2 power 4, you will get 15 times 16. That is 240. A degree 2. Okay, so now for the other term, x power 3, I will use back the same method. It will be x power 2r times x power minus 6 plus r. That means this is same as x to the power of 2r minus 6 plus r, which is x cubed. Then now cube 3 equals to 2r minus 6 plus r. Okay, so this minus 6 move to the other side becomes 9. It will be 3r, therefore my r is 3. So coefficient of x cubed, it is when r equals to 3. Just substitute back into all these 3 terms. Alright, so from here you will get 6c3, 2 to the power 3, a to the power 6 minus 3. So 6c3 is 20. 20 times 8, it will be 160 a cubed. Alright, and now from the question is mentioned that they are equal. The coefficients are equal. So now I just need to equate these two equations, these two coefficients, to find out my a value. And when you look at when you look at the question over here, it is non-zero constant a. And then just mention value, only one answer from this working. So which means now I can just cancel or divide the whole equation by a squared. Okay, so probably I just divide by a squared. Then I will get 240 equals to 160a. Therefore, my a is 240 over 160. So then when you simplify, this is going to be 3 over 2. So that is my solution. Okay, now part B, find the coefficient for x degree 6 for this expansion. Alright, so now since we have found the a, so the a is 3 over 2. So I will get 1 minus x cubed times 2x squared plus a over x to the power 6. Okay, because in the question is mentioned that the coefficients of x cubed and x6 are equal before you start solving a. Alright, that means this a applies to the b as well. So now I will replace the a by 3 over 2. You can replace, right? Or you can just direct find. Okay, so for this case, probably I will just direct find first because this is x6. Just now we have solved x6, right? x6 is this result. Okay, but this is just for the second bracket. So now I just do the expansion first. So 1 times the bracket and minus 3x minus x cubed times the expansion. So I will be getting 2x squared plus a over x degree 6 minus x cubed times the summation. Okay, so by right, okay, I will just write like this. 2x squared plus a over x degree 6. So now, if you want to get a degree 6, here we already found just now. And then this part, I can get x cubed just now, okay? So to get x degree 6, there is an x cubed outside. So it means that I just need to consider the coefficient for x cubed in this expansion. Okay, that means now, basically, just now we already solved. So that means this is same as, okay, here I should get x cubed. Right, x cubed. So which means to find the coefficient for x degree 6, I will say the coefficient, so coefficient of x degree 6 equals to coefficient of x degree 6 in the first expansion minus coefficient of x degree 3 in the next expansion, in the same expansion. Because you are given the x degree 3 here. And from the part A, okay? So from part A, the both coefficients will be the same, right? Therefore, from part A, coefficient of x degree 6 equals to coefficient of x degree 3. That means now, basically, your answer, coefficient for x degree 6 here, no need to do any calculation of x degree 6 in 1 minus x cubed times this expansion it will be 0 because they are the same. Right? So that's why only 1 mark. Okay, now for question number 6. The equation of the curve is this. Now find the coordinates of the point. So only 1 point on the curve at which the gradient is 4/3. So now y equals to 2 plus. Okay, the square root I will change to degree half because I need to find gradient. This gradient is same as dy over dx. So from here, my dy over dx is going to be differentiate 2, you get 0. This half you can bring it down. You have to bring it down because of the formula. Differentiate fx degree n. This is n fx degree n minus 1 and then f prime x. Right, so now from here, bring down the half, rewrite the whole function. And now your degree is no longer half. You have to minus 1. So half minus 1, it will be negative half. And then differentiate the bracket. So when you differentiate brackets, 25 becomes 0. Minus x squared is negative 2x. Then now simplify first before we proceed. So now half and 2 cancel. So I still get the negative degree here, means I will just move it down. That means basically you are getting negative x, which is from the bracket, over square root of 25 minus x squared. So this is your dy dx. And now gradient is 4/3. So dy dx is 4/3. So now dy dx equals to 4/3. That means 4/3 equals to negative x over square root of 25 minus x squared. Now we need to solve this. Okay, then from here to solve this, because there is a square root there, I will take square both sides. Okay, so I will square both sides to eliminate the square root. So left hand side, I will be getting 16/9. For right hand side, once you square the negative, it's no longer negative, it becomes positive. And then bring in the square to the numerator and denominator. So the numerator becomes x squared. Denominator, the square root and square will be cancelled off. Then I will be getting the quadratic function. And now to get the x, because the question is to solve the point, so just cross multiply. I will get 16 times 25 minus x squared equals to 9 times x squared. And now we do expansion. So 16 times 25 is basically 400. Then minus 16x squared equals to 9x squared. And then the minus 16x squared will be moved to the other side. So 16 plus 9, it will be 25. So I will get 400 equals to 25x squared. Therefore, my x squared is 400 divided by 25, which is 16. And now, x squared equals to 16, which means your x will be plus minus 4. Okay, so how do we decide which x? Because when you look at the question, it's mentioned point, only one x. So now we have to check the gradients, 4/3. Do we get 4/3 for these two x values or just one x? Alright, so now we need to do checking because initially there's just square root. We eliminate the square root by taking square both sides. That's why we need to check. So now I will just substitute back into my dy dx. When my x equals to 4, my dy dx is this expression. So I will get dy over dx is negative x over square root. So negative 4 over square root of 25 minus x squared. So from here, right, you will get negative 4 over, this is square root 9, which is 3. Okay, when x equals to 4, you get negative 3, which is wrong. right? Because your gradient is 4/3. So from here, this is omitted. Therefore, your x will be -4. Alright? So this is one way to show this, or another way is you can just use this method. Okay, or given dy dx equals to 4/3, which is greater than 0. So your dy dx equals to -4 over square root of 25 minus x squared. So in order to get positive, not -4, negative x. Right. So from here, which is positive, wait, let me check first. Okay, so your dy dx is this result. So for your information, we know that this square root must be positive, right? Because our dy dx is positive. So then that means your square root of 25 minus x squared must be positive. Okay, we know that this is always positive. So when this is always positive, which means, right, this minus x should be positive. So minus x should be positive. That means your x should be less than 0. Hence, your x is -4. Okay, this is the explanation on choosing -4 instead of +4. Or another method is you just replace. Alright, so from here, my point. So when x equals to -4, you need to get the y. So go back to the question. Your y is 2 plus square root of 25 minus x squared. So from here, you will get 2 plus square root of 25 minus 4 squared. That means this is 2 plus 3, which is 5. That means, okay, at last, my point is going to be with coordinates -4 and 5. So that's the solution of this question. Okay, question number 7a. Show the identity. So since left side has two terms, I will start from the left hand side. So now sine theta over 1 minus sine theta minus sine theta over 1 plus sine theta. Okay, so for the denominator, I will combine both denominators first. It will be 1 minus sine theta multiplied with 1 plus sine theta. So it looks like cross multiplication. So then I will be getting sine theta multiplied with 1 plus sine theta, then minus sine theta multiplied with 1 minus sine theta. Okay, so now from here, just do expansion. Then I will be getting sine theta plus sine squared theta. Okay, the minus sine theta group together, multiply with 1, it will be minus sine theta. Then this minus sine theta, you times by minus sine theta, it will be plus sine squared theta. Now for denominator, I'm going to apply a squared minus b squared formula. That is a minus b times a plus b. So now you are given the right side. I will just change to a squared minus b squared. That means you will be getting 1 squared minus sine squared theta. So then from here, I will cancel off the sine theta. So sine squared theta plus sine squared theta, you will get 2 sine squared theta. Okay, now look at the question over here. You need to get tangent. Okay, so it means that now for the 1 minus sine squared theta, I need to change to another form, which is using the identity. So the identity is sine squared a plus cos squared a is 1. So now you are getting 1 minus sine squared. So it means that I move the sine squared to the right side. It will be just cos squared. Okay, so I will change this to over cos squared theta. So sine squared theta over cos squared theta, it will be tangent. Therefore, 2 tangent theta squared. Okay, 2 tangent squared theta. Because sine squared over cos squared is tangent squared. So with this, I have proven the identity. Now B, hence. Hence means use the previous answer. Solve the equation. These two terms already simplified just now equals to 8, where the theta between 0 and 180 degrees. So here, instead of solving the left side, okay, so the left side, I will just change to right hand side. That means it will be 2 tangent squared theta minus equals to 8. Right, so here I will just write sine theta over 1 minus sine theta minus sine theta over 1 plus sine theta equals to 8. That means the left side will be changed to 2 tangent squared theta. That equals to 8. Now from here, and look at this interval. Your theta is defined from 0 to 180 degrees. So first of all, I need to get my tangent theta, which means I divide by 2. So tangent squared theta is 8 over 2, which is 4. Then now my tangent theta, it will be plus minus square root 4. That is going to be plus minus 2. So now, when tangent equals to plus and minus, we refer to the quadrant. It will be in first and second quadrant. Okay, so now angle will be here. But then, when you look at the quadrant, these two angles will be the same. So I have to find out what is my basic angle. Basic angle will be the orange color. That is inverse tangent 2. I will just take a positive value, and you will be getting 63.4 degrees. So which means this orange color is 63.4 degrees. Okay, so now my actual angles will be the blue color. So it means that my theta is going to be first value 63.4, and the next value is 180 minus 63.4, because that is the major angle and it is in the second quadrant. Then from here you will be getting 63.4 degrees and 116.6 degrees. So that is your theta. Okay, now next question number 8. A geometric progression has first term A, common ratio R, sum to infinity S. The second geometric progression has first term A, common ratio, capital letter R, and sum to infinity 2S. Show that the lowercase letter r equals to 2 capital letter R minus 1. Okay, so now I will write for geometric progression 1, sum to infinity. Now, for your information, if let's say it is geometric progression with A and R, A is first term, R is common ratio, S infinity is A over 1 minus R. Okay, so now here I will write your S to infinity is S equals to A over 1 minus R. For the second geometric progression, okay, it's mentioned S sum to infinity is 2S. So replace the S infinity to 2S. And then remain the first term as A, then over common ratio is is capital letter R. So now when you want to show this statement or equation, I will just solving these two equations because I don't want the S. Okay, so I will just substitute first into second. So I will replace my S here, my S in the second equation by the first equation. That means I will be getting 2 of A over 1 minus lowercase r, lowercase letter r, equals to A over 1 minus capital letter R. Then from here, my A will be cancelled off because They are both the numerator. Okay, and now to get this, I need to get the r, the lowercase letter r, as a subject, which means the easiest way is just multiply, cross multiply. Alright, so I will be getting 2 times 1 minus capital letter R equals to 1 minus lowercase letter r. Then just do expansion. 2 minus 2 capital letter R equals to 1 minus R. So to get the R as a subject, this minus R, I will move it to the left side, and all these terms will be moved to right side because I need to get positive R. So positive R is 1 minus 2 plus 2 capital letter R. That means it will be minus 1 plus 2R, and now I rearrange. That becomes 2 capital R minus 1. So that is my solution. Okay, now next question. It is now given that third term of the first progression is equal to the second term of the second progression. Okay, so now for your information, if it is geometric progression, the nth term is ARn minus 1. So remember, first geometric progression. Okay, so now here I will write the term T3 of GP1 equals to T2 of GP2. So just now, your GP1, right, GP1, you have A and R. GP2, you have A and capital letter R. So from here, now given third term supposedly AR squared. So it will be AR squared. Second term is AR. When you refer to this formula, replace the n by 2. So 2 minus 1 is 1. AR. So now I'll get A capital letter R. So from here, I can just divide by A, cancel off the A from both sides. Then I will be getting R squared equals to capital letter R. This is my first equation. Okay, now we need to get S in terms of A. Now, from the second equation, we have found here. So R equals to 2 capital R minus 1. So from A, R equals to 2 capital R minus 1. Now, from this question, you need to leave your answer in A. That means we need to find out what is the R. Right? So, and then express S. Remember, just now the S was the sum to infinity of the first progression. Right? So now I will have to find small letter, the lowercase letter r, so that I can find my sum to infinity for the first progression. So it means that I have to eliminate the capital letter R. So I will replace my capital letter R by R squared. So I substitute first into second. R equals to 2 of R squared minus 1. Then I'll rearrange this. I'll get R equals to 2R squared minus 1. Move this R to the right side. You will get 2R squared minus R minus 1 equals to 0. Okay, and then factorize this quadratic equation. You will get R minus 1 times 2R plus 1 equals to 0. So you can factorize this using calculator, or you can just use this method. So to get 2R squared is 2R times R. To get 1, it will be 1 times 1 first. Okay, the sign for the last column depends on here. Minus times plus is a minus. So one of them is minus. But since we need to get minus R, that means it should be minus 1 for the first term, and second term is plus, because when I times, I get negative 2R, and this is plus R. So at last, I will be getting 2R squared. This is minus R when you plus together for the middle term, and then minus 1 times 1 is plus 1. So I'm getting back the same quadratic equation. So you have two ways to do it. Either you use the factorization method, or you use calculator. Okay, then from here, either R minus 1 equals to 0, or 2R plus 1 equals to 0. So your R equals to 1 or R equals to negative half. For your information, right, for geometric progression, R cannot be 1. So R cannot be 1. Therefore, your r must be negative half. So then your s is a over 1 minus r. Here we have found it in the previous part, which is the first equation. Right? Therefore, now just replace the r value and then you will get the answer in terms of a. So this is going to be a over 1 minus half. So 1 minus half is 3 over 2. So I will get a divided by 3 over 2. So now simplify it, it will be 2 over 3a. So that is your S. Okay, next question, number 9. The diagram shows a circle with center A and passing through the points B. Okay, this B is on the circle A. The second circle has center B and passes through A. Alright, the tangent at B to the first circle, this is a first circle, this is a tangent, intersects the second circle at C and D. Now the coordinates of A are minus 1, 4. So here minus 1, 4. And the B will be 3, 2. Now first part, find the equation of the tangent CBD. Okay, how to find this line? Now for your information, firstly is mentioned tangent CBD. That means, right, this tangent CBD, that means from A to B, it will be 90 degrees. Because tangent means it is perpendicular to the center. Right, so now to find this straight line, we need to find the M. What is the gradient? So since the AB is perpendicular to CBD, that means I will say this is M1, this is M2. So means that M1 times M2 is minus 1 from the perpendicular property. Right, then now from here you should find what is your M2. Then now just use the points B to form the straight line equation. So that means now firstly I have to find what is your M1. M1 is basically the MAB. Okay, so that's the idea to solve this part A. So MAB. So the gradient formula, M, let's say you are given 2 points. Okay, I give you the general formula. Point x1, y1, x2, y2. The gradient is M equals to the difference of the y over the difference of the x. Okay, so now here MAB, I can just use 4 minus 2 over minus 1 minus 3. That means you are getting 2 over minus 4, which is negative half. Alright, so that is MAB. Now then MBCD or CBD. Okay, so MAB times MCBD equals to minus 1. So MCBD is negative 1 over MAB, which is negative 1 over negative half. Then I will get 2. So now equation of the tangent CBD. Okay, I use the point, right, that passes through point B, because the C and D are unknown. So I just use the points B, which is with coordinates 3, 2. And the M is 2. So I will use the formula y minus y1 equals to M bracket x minus x1. So my x1 is 3, my y1 is 2. Then from here, you will get y minus 2 equals to the M is 2. So 2 bracket x minus 3. Hence, you will be getting y minus 2 equals to 2x minus 6. Then the minus 2, you move to the other side. Your y is 2x minus 6 plus 2 is minus 4. So this is the equation of the tangent. Okay, B, find the equation of the circle with center B. Right, refer back to the diagram. So from here, just for information, right, the circle B, this is a circle B, center is given 3, 2. I just need to find out what is my radius here. This AB is also my radius. So my radius is the length of AB. So now I have to find out what is the length. Okay, so for your information, if you are given 2 points, point x1, y1, x2, y2, okay, distance equals to square root of x1 minus x2 squared plus y1 minus y2 squared. Or you can write x2 minus x1 squared plus y2 minus y1 squared, up to you. So from here, I know that my r, radius, okay, probably I just write down radius of B, which is r, equals to AB. So now I will rewrite my points A and B. -1, 4, 3, 2. So A is -1, 4, B with coordinates 3, 2. So now use this formula. It will be -1 minus 3 squared plus 4 minus 2 squared. Then here is going to be square root of, the first one is -4, you square it, it will be 16. Then 4 minus 2 is 2, 2 squared is 4. So you get square root 20. That is our R. So now, equation of the circle with center B with coordinates 3, 2 and radius square root 20. Now our formula for the circle is equation of circle with center AB and then radius R. Okay, radius R, that is x minus a square plus y minus b square equals to r squared. Okay, that means from here I will get x minus 3 squared plus y minus 2 squared equals to square of the square root 20. That means you will be getting x minus 3 squared plus y minus 2 squared equals to 20. So that's all for the parts B. Okay, see, by calculation, find by calculation the coordinates of C and D. Okay, so now let's look at the diagram. So basically, we have found this equation, the equation of the circle, and we have found the line. So then the C and D are the intersection between the circle B and the circle with center B and the straight line DBC. So I just need to solve the simultaneous equations, okay, of the parts A and also parts B. So now I will rewrite x minus 3 squared plus y minus 2 squared equals to 20 as a first equation. This is from parts B. Then from parts A, it is y equals to 2x minus 4. So here, y equals to 2x minus 4. Okay, so now, when we need to solve this, basically, you can get what is the y, then you substitute back into this. Okay, if you do not want, right, because here I need y minus 2, right? This is just y. What to do is, I direct find what is my y minus 2. Then I can just replace directly. It's all up to you. Okay, so now from here, I will just say my y minus 2 means I minus 2 for the whole equation. it will be 2x minus 4, then minus 2. Then this becomes 2x minus 6. So I will replace my y minus 2 by 2x minus 6. This is my second equation. Or otherwise, you can just substitute directly. No problem. Okay, so now I substitute second into first. X minus 3 cubed remains. So y minus 2 squared, it will be replaced by the second equation, which means I will write 2x minus 6 squared, that equals to 20. Then from here, just do the expansion. We have this quadratic expansion. A minus b squared equals to a squared minus 2ab plus b squared. So when you square the first bracket, I will get x squared minus 6x plus 9. And then for the second bracket, it will be 4x squared minus 24x plus 36. And there is a 20 on the right side, so I will just move it to the left hand side here. So it becomes minus 20 equals to 0. And now I will simplify this because you need to find x coordinates. Okay, that's the reason I eliminate the y. So now I should get 2x because of 2 points C and D. So now x squared together with 4x squared, it will be 5x squared. Then minus 6x minus 20x, you will get negative 30x. Right, lastly, the remaining terms, 9 plus 36 minus 20, you will be getting plus 25 equals to 0. Now this whole equation can be divided by 5. I simplify first. It will be x squared minus 6x plus 5 equals to 0. And now this quadratic equation can be factorized. So it will be x minus 5 times x minus 1 equals to 0. You can factorize this using calculator. Okay, or you can just use this method. X times x is x squared. 5 must be 5 times 1. So the sign for the 5, it will be depending on this. Minus times minus is a plus. So both will be minus. Then now when you do expansion, when you multiply first and third column, it will be minus 5x, then minus 6x. So here will be x squared. Then you times together for the third column, it will be plus 5. The middle column, right? Wait. Okay, mistake. The second here is minus x. So when you plus, right, you plus the middle column, it will be minus 6x. That's why you are getting the same term. So now your x minus 5 equals to 0 or x minus 1 equals to 0. Because multiplication of two terms equals to 0 means that one of them must be 0. That means I'm getting 5 or 1. But then now, okay, so from here, obviously your D will have smaller x compared to the C. So x coordinate of D will be 1. And then x coordinate of C will be 5. Okay, so that's all for the working. Right, now question number 10. The diagram shows the sector CAB, which is a part of the circle with center C. Center C. Okay, CAB, that means this is the sector with center C. A circle with center O and radius R lies within the sector and touches it at DEF. Okay, here touches. Where COD is a straight line, COD, okay, and the angle ACD is theta, okay. Now find CD in terms of R and sine theta. CD is this straight line. Okay, when you look at here, this is R, radius, this is center, and this is a straight line, touches. The meaning of touches means it is tangent. Okay, that means CA is tangent, right? CE is tangent line, right? I would say CEB is a tangent line because of touches. So when touches means here is 90 degrees. And now you need to find out what is your CD. So basically, this is R. Here is R because it's a radius. I just need to find out what is my CO. Then I plus with the R, that will be my CD. Okay, now theta. Here is theta. Okay, and then now we need to find out what is my CO. So when you look at CO, right? So this theta, opposite side is R. This is the opposite side. The CO, because we need to find CO. CO is a hypotenuse, right? So can see clearly, this one is hypotenuse. This is opposite side of the radians or of the theta. So opposite and hypotenuse, that is sine. Okay, so I will write sine theta is FO over CO. So sine theta is FO over CO. So my FO is R. Therefore, my CO, I will just move up to the left side and the sine theta move down. It will be R over sine theta. Okay, so now I need to find CD. So CD is CO plus OD. So CD equals to CO plus OD. Then now it will be R over sine theta plus R, because my OD is the radius of the circle. That's all for this A. Okay, now next part is now given that R is 4, theta is pi over 6. Find the perimeter of sector CAB in terms of pi. So now you need to find sector CAB. Okay, so this whole length. That means you need to find what is your CA plus CB plus arc length of the sector ADB. Okay, so from here, the CD, we have found the CD. Basically, CA is same as CB is same as CD, because that is the sector. Okay, which means your CD is the radius of the sector CAB. So same goes to this. This is the radius. Okay, here is the radius of the big sector, of the sector. So from here I will write CA same as CD same as CB. So CA same as CB same as CD, and it is same as the previous, which is R over sine theta plus R. So R over sine theta plus R. And now given R is 4, so now you just replace 4 over sine 1 over 6 pi plus 4. So this is going to be 4 over sine pi over 6 is half, then plus 4. So then this is 4 over half is 8. 8 plus 4, 12. So I found two lengths, which is 12. So here is 12. Now I just need to find out what is my arc length of sector ADB. So arc length of sector ADB, you refer to this formula. If the angle is theta, this is a R, radius is R, so the arc length is theta R. So means that now I need to find out what is this angle. Okay, so from here I know that this is radius. Look at here. Here is radius. Okay, this is also radius. So which means the CAD is same as sector CDB. Okay, these two sectors are the same. So which means if here is pi over 6, that means this angle is also pi over 6. Right? So which means I will say that the angle ACB is 2 times of pi over 6. Okay, so angle here will be 2 of pi over 6, which is 2 theta. Then I'll get 1 pi over 3. Right, so I will write down in my working there ACB, angle ACB equals to 2 of angle ACD. That means this is 2 times 2 theta. I will write 2 theta, which is 2 times pi over 6. Then you are getting 2 over 3 pi. 1 over 3 pi, sorry, 1 over 3 pi. Okay, so the arc length of sector CAB equals to, now when you look at this whole sector CAB, the theta already found, the R becomes 12. Okay, CA times the angle. So which means this is CA times angle ACB. That means it's going to be 12 times pi over 3. Then I will get 4 pi. So now perimeter of sector CAB equals to CA plus CB plus the arc length. So CA plus CB plus arc length of sector CAB. So this is going to be 12 plus 12 plus 4 pi. Then I will be getting 24 plus 4 pi. So this is my working. Okay, part C. Find the area of the shaded region in terms of pi and square root 3. Okay, now let's look at the diagram again. Area of the shaded region. Okay, so now I will erase this first. Okay, so from here, basically, if you see clearly, area of the shaded region is basically 2 times of these two triangles, area of the double of these two triangles minus area of the sector. Okay, so to get area of the triangle, right, since just now we have found that, okay, since just now we have found that here is 12, here is 12, right, and then you are given R, see here, given R equals to 4 and pi R theta, the theta equals to pi over 6. That means I know that here is 4, so which means this is 8. Okay, because total is 12. So now I know that this is 8 to find the triangle, but unfortunately I do not know what is this, right? Otherwise I can just use CF times FO then times half. So now I need to find out what is my angle over here, because I know the R is 4. So I know the FO and CO, right? So now I need to find out what is this angle. And it's mentioned that the other angle is pi over 6. So refer to this right angle triangle, right? So angle COF will be another pi over 2 minus pi over 6. So that the total angle in the right angle triangle is pi. 180 degrees. So I will write down this angle first. Then after that, I use the sine formula to get the area of the triangle. So angle COF, right? So I will write down here. Angle COF equals to pi over 2 minus pi over 6. That is going to be pi over 3. So now I will draw the triangle. Okay, draw the triangle. So this is pi over 3. Here is 4. And this is 8. Okay, I should draw in the other way around. So it will be like this. Right. Let me check. This is 8. Sorry, this is 4. Excuse me. Okay, so now if you have this triangle, right angle triangle, right, even it is not right angle triangle, you also can use this method. Our formula is this. As long as you know two sides and the angle bounded by the two sides, so the area is half AB sine theta. Okay, so from here I will say area of triangle CFO equals to half COFO sine angle COF. Okay, so then from here I will get half CO is 8, FO is 4, sine pi over 3. Then from here, okay, basically you can simplify. So 8 times 2 is 16. Sine pi over 3 is square root 3 over 2. Then at last you are getting 8 square root 3. Okay, then now, later I just times 2 to get the, because I have found here. So I just times 2 to get the whole quadrilateral. Then now I minus the angle, the area of the sector. Okay, so just now we have found this angle. So you just double it. Right, so FOE, angle FOE, double of angle FOC. So FOC is same as COF, right? So it's double of pi over 3. So I get 2 pi over 3. Now, for your information, when you look at this sector, okay, look at this sector. The R is 4. As long as you know the angle, we can find the area of the sector. Okay, so I give you the general form. Let's say this is a sector. Here is theta. This is R. So your area is half R squared theta. So from here, I will write area of the sector. So let me label the sector first. The sector is FOE, right? FOE. Is half of 4 squared. The theta is 2 pi over 3. Then here you will be getting, okay, simplify first. So 2 and half cancel. So 16 over 3 pi. Right. So now area of shaded region is 2 of its square root 3 minus 16 over 3 pi. So here I get 16 square root 3 minus 16 over 3 pi. You can leave it in this form. Okay, now next question. Question 11. Functions f and g are defined as follows. A. Find the expression for fg. So fg is a composite function. So fgx is f of, replace the g first, 2x plus 1. Okay, so now when you compare, here x, here 2x plus 1, that means all the x on the right side of the fx will be replaced accordingly. Then I will be getting equals to 2x plus 1 squared, then plus another 3. Okay, so that's all for your fg, because it's only 1 mark, so no need to do expansion. Now B, find the expression for fg inverse and state the domain for fg inverse. Okay, so now I will rewrite this. Let y equals to fg x. So that means this is 2x plus 1 squared plus 3. So then, to get the inverse function, I will get the x as a subject. So it means that this plus 3 will be moved to the other side. Then I will be getting 2x plus 1 squared equals to y minus 3. So now my 2x plus 1, eliminate the square by taking plus minus square root of the other side. Then the plus 1, the plus 1 will be moved to the other side, becomes minus 1. So I will get 2x equals to minus 1. Okay, plus minus square root of y minus 3 first. Then my x, it will be minus 1. Okay, now here I will have to decide whether I choose plus or minus. Now, this whole expression is the range of the g inverse later on. Okay, because once you get the x, I will just write this as fg inverse x. I change the x into fg inverse. Then minus 1, leave it blank first. The y in the expression will be changed to x. Okay, so now how to decide plus or minus sign over here? So this whole expression is a range. So now look at here. Range inverse, okay, range fg inverse is basically domain fg. Okay, so now look at the composite function diagram. To get fg, okay, we solve the g first. So this is g followed by f. We always map, the function always map domain into range. That means this circle is basically domain g, and at the same time also domain fg. Okay, this will be range g, and then it's also domain f. And then lastly, this is range f and also range fg. So now by looking at this, range inverse equals to domain, range inverse fg equals to domain fg. So now your domain fg is same as domain g. So this is same as domain g. Okay, so now look at the domain g. Your domain g is greater than negative half. Alright, that means this domain g, alright, that means this is greater than negative half. So domain g, x is greater than negative half, which means your range fg inverse will be fg inverse greater than negative half. Okay, so in order to get greater than negative half, since this is negative 1, we should choose plus. Right, therefore here I choose plus. No longer plus minus. Because if you choose minus, it will be less than the negative value. It will be more negative. I would say it will be more negative. Right? Therefore, this is your fg inverse. Now, the question says domain fg inverse. Right? So now, domain fg inverse equals to range fg. So now, refer to the domain, refer to the G first. Okay, so I will write down my Gx is x greater than negative half. Right, so what is my Fg? So refer back to the Fg. My Fg is 2x plus 1 squared plus 3. So 2x plus 1 squared plus 3. So my Fg equals to 2x plus 1 squared plus 3. So when you look at this domain, this plus negative half, now basically from here I will get a minimum point, because when you do expansion you are getting 4x squared. So the minimum point, okay, minimum point is when you let 2x plus 1 be 0. So when you let this be 0, 0, your x is basically negative half. Right, therefore I will get negative half followed by plus 3. Plus 3 is over here. So it means that my minimum value is 3. So from here, that means minimum value of Fg is 3. In other words, my Fg will be greater than 3. There's no equal sign because this does not include. So from here, I will say my domain Fg inverse is basically same as range Fg. So just copy this result, but change the Fg to x. So it will be x greater than 3. So that's the explanation to get the domain Fg inverse. Okay, now for C, solve the equation Fg minus 3 equals to Gf. So now, what is my Gf? Get the function first. It will be G of Fx. Fx is x squared plus 3. Then now my Gx just now equals to 2x plus 1. So now here, I change my x by 2 into x squared plus 3. So I will get 2 bracket x squared plus 3 plus 1. Therefore, you are getting 2x squared plus 6 plus 1, which is 2x squared plus 7. So now I will substitute into the equation. So Fg just now already found. Fg is this quadratic. Just replace. So the 3 and minus 3 will be cancelled off. Excuse me. Then now just do expansion. So I will get 4x squared plus 4x plus 1. Right side, 2x squared plus 7. So move all the terms to the left hand side. So 4x squared minus 2x squared, 2x squared plus 4x plus 1 minus 7 is minus 6. So I can divide the whole equation by 2. Then now again, factorize this. You will get x plus 3 and x minus 1. So either x plus 3 equals to 0 or x minus 1 equals to 0. That means you get x equals to minus 3 or x equals to 1. Then from here, now you check. This must satisfy the domain f and g, right? So now look at the domain. So domain f is greater than 0. Domain g is greater than minus half. So x must more than minus half and more than 0. Therefore, your x is 1. Okay, so that's the solution of this question. Okay, next question, number 12. The diagram shows a curve with equation where x is greater than greater than or equal to 0, and a straight line with equation y equals to 3 minus x. So there are one curve and there are two graphs here. The first is the curve, the second is a straight line. The curve crosses the x-axis at points A, 4, 0, and crosses the straight line as B and C. Find by calculation the coordinates of B and C. Basically, the B and C will be the intersection points. Right, so y equals to 4x degree half minus 2x. This is the first equation. Then y equals to 3 minus x, second equation. Now I equate them. So 4 square root x, right, 4 square root x minus 2x equals to 3 minus x. And now I square both sides. Or before I square both sides, okay, because we need to find x, right? So don't square both sides here because you have two terms. So I will just move the minus 2x to the other side first and simplify it before I square both sides. So when I move the minus 2x to the other side, it becomes plus 2x. So 3 minus x plus 2x is plus x. And now I square both sides. Because the purpose to square both sides is to eliminate the square root. So bring in the squared. 4 squared is 16. Square root x squared is x. Now for right hand side, just do quadratic expansion. It will be 9 plus 6x plus x squared. So move the terms, the left side term to the right side. I'll get x squared plus 6x minus 16x is minus 10x. Then plus 9 equals to 0. And this can be factorized into x minus 1 and x minus 9. Okay, so then from here, either x minus 1 equals to 0 to get x equals to 1, or x minus 9 equals to 0 to get 9. So these are the two x coordinates. Now show that B is a stationary point on the curve. So whenever you see stationary points, means dy over dx. And it must be 0, okay? dy dx equals to 0. So now refer back to the B. So I will differentiate this curve. So y is 4x degree half minus 2x. So y is 4x degree half minus 2x. So now my dy dx, it will be 4 bracket half x degree negative half minus 2. So then 4 times half is 2. This is x degree negative half. I can just move it down. It will be 2 over square root x. Then minus 2. You will need to show that B is a stationary point. Okay, now we have found two x values, 1 and 9. But by looking at the graph, definitely B is 1, the x coordinate. Then the C is 9 because the A is in between, which is 4 for the x coordinate. So I will write here, when x equals to at B, x equals to 1. Therefore, dy over dx is 2 over square root 1 minus 2. This is 0. So we write here, since dy dx equals to 0 at the point B, then point B is a stationary point. Okay, so that's the solution of this question. Okay, see, find the area of the shaded region. Okay, so let's look at the graph. Area of the shaded region. Okay. So, alright, let me erase this first. Area of the shaded region is area of triangle. Okay, look at here. Area of triangle minus area of this part. This part is the area of the curve towards the x-axis, right? So now I know that here I need to find out what is this value. So this value is counted using the line and at the y equals to 0. Okay, so now I write first y equals to 3 minus x. When y equals to 0, 0 is 3 minus x. That means your x is 3. So now, okay, there is 3. So I will say that this whole triangle minus area of the shaded region, area of the graph. So now I need to find out what is my length here. Okay, because I know that here is 9. Then I know that this is going to be 6. Right? So here at C, y equals to 3 minus x. That means x equals to 9. So your y is 3 minus 9, which is minus 6. So here I know that this is minus 6. That means the length here is 6. Right? So area of triangle equals to half of 9 minus 3 for the vertical distance. For horizontal distance, 9 minus 3. Vertical distance will be 6 minus 0. So 9 minus 3. Then 6 minus 0. Okay. Then here I will get 12 of 6 times 6, which is, okay, simplify first. 18. Okay, now I need to find out what is the area under the curve, which is here, the orange color. So this orange color, this region is below the x-axis. So it means that you need to integrate your graph, right? Integrate your graph from 4 to 9, but have to put a modulus, right? Because the region is below x-axis, then your integration will be a negative value. So I will integrate 4x degree half area under the curve. Okay, area, I would say area bounded by the curve and the x-axis. Because this is not under, it is above, right? So it is integrate from 4 to 9. Then the function, the curve equation. And remember to put a modulus because the region is below the x-axis. So now when you integrate, it will be 4 bracket x to the power of 3 over 4 divided by 3 over 2, sorry. Half plus 1 is 3 over 2 minus 2x squared over 2. Limits 4 to 9. Now I simplify first before I calculate the value. So 4 divided by 3 over 2 is basically 4 times 2 over 3. Then you will be getting 8 over 9. X to the power of 3 over 2. Then the 2 and 2 cancel off, minus x squared. Then limits 4 to 9. Okay, so now just replace the x by 9 first. Then followed by, or minus, when the x is lower limits 4. So 8 over 9 times 4 to the power of 3 over 2, then minus 4 squared. Okay, then from here, the first one you will get 72, then second one is 81, and minus, this minus you bring it in, right? So the first term after the bracket is 64 over 3. Then minus of 4 squared, you will get plus 16. Then from here, you will get negative 43 over 3. And I'm getting 43 over 3. This is the area bounded by the graph and x-axis. But then when you look at the question here, you need to find shaded region. So shaded region is area of triangle minus the area bounded by the curve and the x-axis. Right, so just direct minus. So it means that now area of the shaded region equals to 18 minus 43 over 3. Then here I will get 11 over 3. So that is the area of the shaded region. Okay, so I have completed this whole paper and also comes to the end of the video. Thanks for watching. Please like this video and subscribe to the channel, and also share it with your friends if you enjoy watching all my videos. Alright, and also stay tuned for more upcoming videos. Thank you. Bye.